Okay, y equals 3 f of x plus 6. Now we're going to pretend for all of these cases the original is y equals f of x, and then it's transformed to these. We're not going to deal with the replacement notation today, so that can be completely ignored. That's fine. All right. Now what we do know is we're going to start off with equation, do words and mapping, equation, do words and mapping, equation, do words and mapping for the whole front. Then I'm going to flip over and I'm going to give you words. And then we're going to do equation, mapping, equation, mapping, equation, mapping. And I'm going to do mapping, and we're going to do equation, words, equation, words, equation, words. Because I have to be able to give you equation, words, or mapping, and you have to be able to make the other two easily. Okay? So, this affects, I picked a different color yet. This affects the y. Why? Because it's not with the x. That's why it affects the y. So what we have for y options are vertical stretches by a factor of whatever about the x-axis. We have reflections in the x-axis, and we have vertical translations. Those are our three vertical options we have. So in words, I'm picking between those three. I can either use all three, or I can use 1, 2, or 3 of them, right? But right now, I have nothing affecting my x's. We agree? Transformations have to be said in what form? What order? Yeah. SRT. Stretch, reflect, translate. Stretch, reflect, translate, right? Search. So, in this case, also with verticals, do the numbers ever change between equation, mapping, and words if it's vertical? No. Equation, mapping, words, all the same numbers. So I have a 3 here. I'm going to have a 3 in words, and I'm going to have a 3 in mapping. I have a 6 here. I'm going to have a 6 in words and a 6 in mapping. It's not going to change, because verticals do not change. That's the best thing about them. That's why you have to give it to y equals. Okay? So the 3 represents a what? A stretch. So I have to state that first. Vertical, stretch, by a factor of what? 3 about the what? X-axis. Do I have a reflection? No. How would you know if I had a reflection? The 3 would be negative. Do I ever say vertical stretch by a factor of -3? No, because the negative is actually not a stretch. The negative is a reflection. I don't have a reflection. So do I have to write a reflection if I don't have a reflection? No. I bypass the R. I don't do this part of search. You know what I'm saying? Is there any translations? Yes, that 6 is a translation, correct? What kind of translation is it? Vertical. Vertical stretch, vertical translation. Anything that makes the Y is vertical. We agree? So it's a vertical translation, 6 what? Units up. Because the vertical never changes. You do what you say. So it's a vertical translation, 6 units up. Now my mapping is x, y becomes x, comma. I don't touch the x. Why don't I touch the x? There's nothing affecting the x. The x still is an x, correct? So what am I going to do here? 3y plus 6. Exactly. You use exactly what you need for the y's. The stretches and reflections multiplied by the variable. The translations add or subtract. That's it. That's all. Okay? So you do this one. Do the words and mapping. Yeah. Okay, so we have, this affects the y. So if I do my mapping right away, I can say x, y becomes x stays the same and y is multiplied by a third, and I'm going to subtract 4, because my y in all 3 of these would be the same. Verticals are the easiest. right? So I have a vertical stretch by a factor of what? That is not factor. 1/3 about the x-axis. Is there a reflection? Nope. Vertical translation. What? All right. New one. What's the very first thing you're going to have to do? Get into y equals. Okay, then give me the stuff. So here we have y minus 6. So we're going to have to add the 6 over first. And we get y equals -2 f of x plus 6. And still affecting only the y's. We agree? So I'm going to go to my mapping first and use exactly what those are, because my mapping is the same for vertical. So I get x, and then my y is going to be -2y plus 6. True statement? Okay. Then we do our vertical stretch first. Do we have a vertical stretch? Yes. It's a vertical stretch by a factor of what? 2, not -2, right? About the x-axis. Do we have a reflection? Yeah, it's vertically. So if it's a vertical reflection, that means my y's are positive become negative, my y's that are negative become positive. So I have a reflection in the x-axis. These are the same axis, right? They stretch about it, they reflect in it. And I have a vertical translation . 6 units up. Okay, next one. Try it out. So, we are going to move what first? This is going to be I'm going to guess wrong for a whole bunch of people. What do I have to move first? The 4. You have to do reverse FEDMA to isolate. So we add the 4 first. So I'm going to get 1/3 y equals f of x plus 4. Then what do I have to do? Multiply the entire both sides by 3. What's in front of the f of x currently? A 1. Now remember I told you when you bring that over, you have to, and when you put your vertical stretch in, you have to put it in front of the whole equation, right? We talked about this already. So it's actually not a plus 4, it's a what? Plus 12. 3f of x plus 12. Because you're stretching the vertical translation as well, right? You're not just stretching the one in front, you're stretching the whole thing. Vertical translations and vertical reflections have to be put in front of the entire function. We did that yesterday where we had that -1 went in front of the whole thing and reflected in. Have to do the same thing. So this still only affects my y's. So when I go to do my mapping, I'm going to get xy becomes x comma 3y plus 12. And I have a vertical stretch by a factor of 3 about the x-axis. Do I have a reflection? Is there any reflection? No, because there's no negative, right? And then I have a vertical translation 12 units up. Now, if you're someone who had the 4, which I would suspect is most of you, you should leave yourself a little star, star, star note and say, when I move that vertical stretch over, it has to apply to the whole function. I have to apply it to the whole equation. Okay? Ooh, that sounded awesome. Try this one out. Is it only verticals now? Trying this one out. So I'm going to, quiet please, I'm going to add the 8. I'm going to add the 8 first. So now I have 2y equals f of 3x plus 8. Currently in front of my f I have a 1. And then I'm going to divide each term, so this is one term, by 2. This is one term by 2. So I'm going to get y equals 1/2 f of 3x, does not affect my x because it's vertical, plus 4. Okay, I have to state my stretches first. So I have a vertical stretch by a factor of 1/2. Remember, those are verticals. This is affecting x, correct? These affect y because they make a y. They're stretched by a factor of 1/2 about the x-axis. And I know I have a horizontal stretch. Horizontal always flips from equation. Horizontal stretch by a factor of what? Of 1/3 about b. Are there any reflections? Neither of those are negative. Is there a translation? Yeah, there's a vertical translation. Four units what? Up. I always will do my words first because my words, the numbers with my words, will be the exact same numbers in my mapping. Words and mapping are in a heart. The numbers in words will be in mapping. The numbers in mapping will be the same numbers in words. They are always in a heart. They are always the same. So I'm vertical. All the vertical things will affect my y's first. So I'm going to do my x first. It comes first. So the only thing I have horizontal is a stretch by a factor of 1/3. It's by 1/3. So I'm going to get 1/3. What numbers I have in words are the numbers I have in mapping. They're the exact same thing, right? Then verticals by 1/2. So I'm going to have 1/2 y. And then 4 up. So I'm going to go up 4. Mapping in words, the same. Right? So because someone in my AP class thought they were funny. That's fine. Destroy your lives, but that's not true. All right. Didn't even see that till right now. Yeah, they're just. That wasn't funny, but okay. All right. Didn't even see that over there. All right. Please move. Don't be frozen. Negative 1/3 y equals f x minus 3. So you could have a plus 0 at the back, but there isn't one. Anything there. So I'm going to multiply by -3, the whole equation. It just happens to only have one term. There's no vertical translation. So I'm going to end up with y equals -3 f x minus 3. So we know that this affects x, correct? And we know that this affects y. Is there anything back here? The way back? No. If it makes you feel better, you can put a plus 0. Yeah. You could put a plus 0 at the back, could you not? Do we talk about that though, if it's a plus 0? No. So, let's do our words first. So we have a vertical stretch by a factor of what? About the x-axis. Do we have a horizontal stretch? No, there's nothing in front of the x. Do we have any reflections? Yes. Yeah, we have a negative with the 3, so we have a reflection in the... Do we have any translations? What kind? We have a horizontal translation. Three units. Right, because it's always opposite when you come from the equation. But mapping and words are the same. So I'm going to add 3, right? Mapping and words are the same. They mean the same thing. They're in a heart. Mapping and words, same thing. Not the foolish equation thing someone wrote about. So we have x, y. All the vertical things affect the vertical. So we have a vertical stretch and a reflection. It's -3 for our y. So we're going to get -3y. And our x is always opposite for one from equation or the same for one from words. I have to go 3 units right. So I'm going to go x plus 3. Everyone doing okay? All right. I'm going to show you something you're going to write at the very top of the page. Transformation equation, the form you need it to be in is this. Y equals A, F, B, X minus C plus D. Everyone will have the A and the D right. This is where life goes a little rough. If you want to state your horizontal stretch correctly and your translation correctly, you have to GCF your horizontal stretch or your reflection out. In order to get your horizontal translation correct, it needs to be sitting in its own bracket with a 1 in front of the x. So before I go to use an equation, I always make sure I have a 1 in front of my x. And if I don't, I have to GCF that x out, that horizontal stretch or that reflection out. Now on the test, there'll be quite a few questions where it's not pulled out. You're going to get a question wrong because you're going to tell me the horizontal translation is this, and it's not. So an example would be, we're just going to do horizontal right now. Y equals F, 2x plus 4. What people will tell me is they'll say horizontal stretch by a factor of 1/2 about the y-axis, which is 100% correct. 1/2, it flips. Then they'll tell me a horizontal translation 4 to the left, and you will be wrong, and that answer will be there, and you will be wrong. Because the only time you can state a horizontal translation is if there is a 1 in front of the x. Is there currently a 1 in front of the x? No, there is a 2. So before we even attempt to write anything, we will always check, is there a 1 in front of the x? Before I do any translation question, I get to a diploma, I go, is there a 1 in front of the x? Yep, okay, I can actually keep going. So you have to have it in y equals and a 1 in front of the x. In y equals and a 1 in front of the x. That's what you need to check for before you attempt any question. Okay? So I'm going to write this here. You need to check for 2 things. The equation needs to be in y equals. And the second thing, a 1 in front of the x. So you can do absolutely nothing, no statements of translation, no mapping, no nothing, until your equation is in y equals, which you guys have all bought. I've sold it, you bought it. You're all doing that. That's totally fine. And you have to have a 1 in front of the x. If you don't, you will get your horizontal translation wrong every single time, and I promise you the answer to your oopsie will be there. It gets picked often, sometimes more than the correct one, which is scary. Okay? So, step 1, y equals. Cool, got that. Step 2, a 1 in front of the x. Nope, don't have that. So I have to do that before I can state anything. Is there anything vertical happening on this one? There's no stretch, there's no translation. If I do the y, there's absolutely nothing happening, right? There's a 1 here and a 0 there. So this is all affecting my x. Before I go to state anything, I have to take that 2 out. So I'm going to get f bracket 2, and then I have to take the 2 out of these 2 terms. When I take the 2 out, it's a GCF. When you take out a GCF or a greatest common factor, you are dividing. We agree? Okay. 2x divided by 2 is just what? 1x. Sweet. It's looking better. I need a 1x in order to state my transformations, right? And then I go plus 4 divided by 2 is 2. So this isn't actually a horizontal translation for left. It's actually 2 left. This is a 2 left horizontal translation. So if you do not take that 2 out, you're going to get it wrong. True statement? Okay. So this one has a horizontal stretch by a factor of what? 1/2 about the y-axis every single time. It's always about the opposite. So it's horizontal, it's about the y-axis. And then we have a horizontal translation what? Yeah, 2 units left. So my mapping is going to be xy becomes something y. I can fill the y in right away because the y is not changing. We agree? What's my x going to be? Words in mapping are the same. So 1/2 x minus 2. Words in mapping are the same. Words in mapping are the same. Multiply by 1/2. I need to do 2 left. Minus 2. Okay? Is it starting to click? Starting to click? We're going to do a whole bunch till it finally clicks. And then we're going to go on a 10-day holiday. You're going on a 10-day holiday. I have 1 holiday day, and I have 4 days of 2 teacher convention, 2 faith days. And knowledge will just fall out. I'd rather be here personally. Whatever. Okay, let's try this one. Whenever you GCF out a half or a fraction, you get a bigger number, and this is why. Join me, marker. So I take out a half. When I take out a half, I divide by a half. So I'm going -6 divided by 1/2. What do you do when you multiply or divide by a fraction? You multiply by the reciprocal. You invert and multiply what you're dividing by. So you go -6, bless you, times 2/1. So it's actually -12. Okay? Do you think that they'll have the answer with -3? 3 to the right. Yeah, they absolutely will. So these are going to be the options. They're going to say 6 to the right, 3 to the right, and then 12 to the right. And the only one's right is 12 to the right, but they'll have the other two. They'll have the version you forget to take it out. They'll have the version where you actually, you divide by 2, not a half. Because -6 divided by 2 is a half. Now, this is what you can do every single time. When you take out a GCF, you're literally GCFing, you're dividing, you're pulling it out. You can check your math by putting it back in and see if you get back what you have, correct? So whenever I do the GCF in the X, I will always put it back in and see, did I get back what I had? And that's how you'll check. So if I go a half times X, I get a half X. If I go a half times -12, I get -6. Whew, genius, okay? What if we did the bad one, the wrong one? So what if we did this? F 1/2 X minus 3, which is what a whole bunch of you will have, and you'll just not admit it to me. If I put that back in, I get 1/2 X minus 3/2. Was that this? No, you should catch your error when you distribute it. 1/2 X minus 3/2. Something's wrong, right? So when you GCF, always check back. Like if I check this one back, 2x plus 4. Hey, it's the same thing, right? You should, I don't want you to rewrite the equation back. Just check it and then carry on. Make your x a 1, check to see if your math is right, then do your stuff, okay? All right, so this one is going to be a horizontal stretch by a factor of what? Sorry? Yes. About the y-axis. Is there a reflection? Nope. I have a horizontal translation. What? xy becomes 2x, obvious, right, plus 12, comma 1. Okay, you try this one. Okay, this one, I'm going to get 3f. I take the negative a third out because I have to have it in y equals, which I already do, and I have to have a 1 in front of my x. So I go negative 1/3, take out 1/3, I get x. And then plus 6 divided by negative 1/3 is actually negative what? So I'm going to have a vertical stretch by a factor of what? Of 3 about the x-axis, yep. A horizontal stretch by a factor of what? By a factor of 3, not negative, about the y-axis. Do I have a reflection? Yeah, it's with the x, so it's a reflection in the y-axis. Do I have any translations? Horizontal translation. 18 units what? Okay. My mapping is going to be x, y becomes, this affects my y. I have a plus 0 in the back, I really want to. That affects my y. So it's just the 3, right? So I'm going to get 3y. What's happening to my x? It's going to be multiplied by negative 3, so is the opposite. X plus 18. Okay. See how you do. Have to get into y equals. So we're going to go f. I'm going to leave that for a second. I'm going to minus the 4 at the back. We agree? Then I have to take a negative 1 out because I need to have a positive 1x plus 3. Do you see how this is one that people might miss because it's just a little negative 1 and you're just like, no, it's close. Like you just don't even think about it. The 2 or a half, people have a better chance. When I put a negative 1 there without anything, I'm like, oh, please don't fall for the mistake. But then I still get the question because I'm nice like that. All right. Is there any stretches? No. There's no number in front of the f, and the one in front of the x is just a 1, so no stretches. I do have a negative 1 in front, though, so I have a reflection in the y-axis. And then I have a horizontal translation. Left, and I have a vertical translation . 4 down. Now remember, stretches have to come first, but the order of stretch doesn't matter. You can go vertical then horizontal. Reflections have to come next, but it doesn't matter. And then translations, it doesn't matter. They have to come last. Reflections are the only ones you can write together. So if there was actually a negative on both, you could just say a reflection in the x and y axis. You wouldn't have to write out 2 sentences if you didn't want to. So this one here would be xy becomes negative x minus 3 comma y minus 4. Okay. Go to your new page. You see there are 5 equations on the front page? Okay. So there's 5 blanks. I'm going to now give you possibly a mapping And then you have to come up with the equation in the words, or the words, and you have to come up with the equation in the mapping. Okay? Once it shows up. Okay. So, the first one I'm giving you this. Oh, who knows? Okay. 2y minus 3 equals f 1/2 x. Okay. The next one I'm going to say vertical. We're not doing any of these, just, doing the equation and mapping for this one. Vertical stretch by a factor of 4 about the x-axis. Reflection in the y-axis. Horizontal translation units. This one, xy, becomes 1/2 x minus 3 y plus 1. Does everyone have the first equation down? At the very least. Okay. Make sure to write this all down. I don't know what you're talking about. It was never there. Clearly it said left the whole time. Cool. So then here I have... Why did my pen just go away? See those 5 questions? Okay, your homework. Try them out.
So this is supposed to be an X, which is fine. What about here?
Oh, man. That's a large eraser. I don't remember what it was. It was... I thought it was an X the whole time. I just hope I didn't put full report. I might have put calculus in the skip. I don't know if I saved it in between. I don't think I did. It's a 6y. I have marked your guys' stuff. Trust me, that is neat. Oh my gosh. This is a thing. Oh no, I did it again.
I'm not even joking. This is, that's what it looks like. And she's more spiced out.